Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the earlier sessions, we have seen various types of random variables, their respective probability functions PMF and PDF, and cumulative distribution functions CDF. Now, also we have seen some illustrations on discrete random variable and continuous random variable. Continuing with the previous sessions, in this session also we are going to deal with continuous random variables. The outline of the session is dealing with illustrations on continuous random variables, the probability density functions and cumulative distribution function. Now, the first illustration is given a PDF of a continuous random variable x as f of x is equal to 6x into 1 minus x for 0 less than x less than 1 is equal to 0 otherwise. You are asked to find out the CDF of x. You are given the probability density function PDF and you are asked to find out the CDF. We have to see the relationship between PDF and CDF of x. What is that? Relation between PDF and CDF of x is small f of x stands for PDF and capital F of x stands for CDF. So, capital F of x is equal to P of x less than or equal to x. And we have seen the probability relation between probability and the PDF, that is two extremes are the lower and upper limit. The another extreme here is minus infinity, another extreme is x. So, integral x is equal to minus infinity to x is equal to x f of x dx. This is the relationship between CDF capital F of x and PDF small f of x. And here you are asked to find out CDF of x when PDF is given. Okay. So, PDF is given as 6x into 1 minus x and you have to integrate within the limits minus infinity to x, f of x is 6x into 1 minus x dx. Integrate this, 6 will be taken outside, minus infinity to infinity x minus x square dx. This should be in terms of x only, because it is a function of x, 6 into, but how the f of x is defined? F of x is defined as 6x into 1 minus x only for the limits 0 to 1. So, you have to break the interval minus infinity to x f of x dx as minus infinity to 0 f of x dx plus 0 to x f of x dx. In minus infinity to 0, f of x is automatically 0 plus 0 to x, f of x is 6x into 1 minus x dx is equal to 6 into, you have to limit 0 to x, x minus x square. I make it convenient for integration. So, this is equal to 6 into x square by 2 minus x cube by 3 for 0 to x. Okay. So, 6 into limit substituted as x square by 2, x is substituted as x itself, x cube by 3, this is your upper limit and lower limit is 0. So, this is the expression 6 into taking LCM 3x square minus 2x cube by 6, 6 gets cancelled. So, your capital F of x is 3x square minus 2x cube in the interval 0 less than x less than 1. You have found out f of x. Now, you have to write f of x in a format so that it is compared with PDF. How to write capital F of x, that is your CDF of x is written as, first start with f of x is equal to 0 and end up with 1 and the answer which you have got 3x square minus 2x cube. This is for the interval 0 less than or equal to x less than or equal to 1. So, for the previous limit for x less than 0 it is 0. You have to start up always with 0 and end up with 1, and in between you have to write down the answer which you have got for the continuous function. Okay. And 1 it is 0 to 1 is defined, x less than 0 is defined. What is the remaining limit? X is greater than 1. So, this is how f of x is written after it is being found out. This is your CDF of x. In this illustration, we have found out the cumulative distribution function of x when f of x, the PDF, is given as a continuous function. In the next illustration, we will have to find out the cumulative distribution function when f of x is defined as a discontinuous function. How it is discontinuous? You have two discontinuities. One is x is discontinued at x is equal to 1, and the again function breaks is and it discontinues at x is equal to 2. There are two discontinuity points, one it is as x is equal to 1 and another one it is at x is equal to 2. Okay. So, now f of x is defined as a x for 0 to 1, a for 1 to 2, minus a x plus 3a for 2 to 3, and in all the other intervals except 0 to 3 it is 0. You first of all, as usual, you have to find out the constant a and then compute the probability p of x less than or equal to 1.5, x less than or equal to 2.5, and determine the CDF f of x. We have dealt with the two continuous random variable illustrations. The first illustration of continuous random variable dealt with the probability, finding the probability when the function PDF is continuous. Second illustration dealt with the finding a cumulative distribution function of x when the PDF is a continuous function. Now, this is an illustration where you have to find out the cumulative distribution function as well as the probabilities when the given PDF is a discontinuous function. Okay. So, discontinuous function. So, first of all, we shall find out the constant a. To find a, again use the total probability is 1. Total probability is 1 means minus infinity to infinity f of x dx equal to 1. So, that is minus infinity to infinity f of x dx. Total interval should be broken into many pieces because there are too many discontinuities. One discontinuity at x is equal to 1, another discontinuity at x is equal to 2. So, how will you change the limits? Minus infinity to 0 f of x dx plus 0 to 1 f of x dx plus 1 to 2 f of x dx plus 2 to 3 f of x dx plus 3 to infinity f of x dx should be equal to 1. In these interval minus infinity to 0 and 3 to infinity, your f of x defined as 0. Only in the 3 intervals 0 to 1, 1 to 2, 2 to 3 it is being defined. Okay. So, what is the corresponding f of x for these 3 intervals? So, first of all 0 to 1, in this interval f of x is defined as a x plus 1 to 2 it is defined as a, and then plus 2 to 3 this is defined as minus a x plus 3a dx equal to 1. Integrating this within the limits a x square by 2 for 0 to 1, a within the limits 1 to 2 plus minus a into x square by 2 plus 3 a x for x is equal to 2 to x is equal to 3 equated to 1. Simplifying this, we get a is equal to 1 by 2. So, this is your first subdivision. Evaluate the constant a. A is found out as 1 by 2. After finding a, as usual we have to go back to the question, substitute this a value in the PDF and get a refreshed PDF. So, what is your refreshed PDF? F of x being a being substituted. Okay, PDF of x is f of x is equal to x by 2 because a is 1 by 2 for 0 less than or equal to x less than 1, and 1 by 2, a is 1 by 2, right, for 1 by 2 for 1 less than or equal to x less than 2, and minus x by 2 plus 3 by 2 for 2 less than or equal to x less than 3, 0 otherwise. So, now this is your refreshed PDF. With this only we have to proceed further to find out the probabilities. Okay. So, what is your second subdivision? You are asked to find out P of x less than or equal to 1.5. So, using the relationship between probability and PDF, minus infinity to 1.5 f of x dx. How will you break this interval minus infinity to 1.5? As minus infinity to 0 f of x dx plus 0 to 1, isn't it? 0 to 1 f of x dx plus 1 to 1.5, because there is a discontinuity at 1 f of x dx. You have to find out this answer. This here it is 0. In 0 to 1 your f of x is x by 2, using the previous one. In 0 to 1 it is x by 2 dx, and in 1 to 1.5, this 1 to 1.5 is within the limits from 1 to 2. Therefore, you have to use f of x as 1 by 2 dx. Okay. Integrate this as x square by 4 within the limit 0 to 1 plus 1 by 2 into x within the limits 1 to 1.5. What is your answer? X square by 4 is 1 by 4 plus 1 by 2 into 1.5 minus 1. So, 1 by 4 plus 1 by 2 into 0.5. 1 by 4 plus 1 by 4 gives you 2 by 4. The answer is 1 by 2. So, P of x less than or equal to 1.5 is equal to 1 by 2. What is the next subdivision we have to do? You are asked to find out P of x less than or equal to 2.5. Again, using the relationship between probability and PDF, you have minus infinity to 2.5 f of x dx. Break the intervals, as I will only use the integrals instead of writing it again and again. Minus infinity to 0, 0 to 1 plus 1 to 2 plus 2 to 2.5. Everywhere you have to substitute as f of x. So, in this interval it is 0, and in 0 to 1 it is x by 2 dx plus 1 to 2 it is 1 by 2 dx plus 2 to 2.5 it is minus x by 2 plus 3 by 2 dx. Integrate and get the answer. Okay, this is a do it yourself exercise. Going to the next subdivision, what is your fourth subdivision? You are asked to find out the CDF of x. CDF of x for a discontinuous PDF. We shall have a small break. Welcome after the break. Before the break, we have seen a continuous random variable illustration dealing with finding probability and finding cumulative distribution function for a continuous PDF, continuous function of a PDF. Also, we have been dealing with a PDF which is discontinuous and finding the constant value and the probability values. Now, we will see constructing the cumulative distribution function capital F of x for a PDF which is discontinuous. In this illustration, we are seeing there are two discontinuities, one at x is equal to 1 and another one at x is equal to 2. Let us see how to find out the cumulative distribution function f of x for this PDF. We have found out a value as 1 by 2, we have found out p of x less than or equal to 1.5 as half, and now we will find out cumulative distribution function capital F of x for this variable, continuous random variable x. Okay. Again mentioning the relationship between continuous random variable and relationship between a cumulative distribution function and probability density function, relationship between CDF and PDF, that is capital F of x and small f of x. capital F of x is written as p of x less than or equal to x. This is equal to integral minus infinity to x f of x dx. Here there are 3 intervals. What are the 3 intervals? One is the interval 0 to 1, another interval 1 to 2 and another interval 2 to 3. We have to find out a CDF for the 3 intervals separately. Okay. First, for the first interval 0 less than or equal to x less than 1, we will find out CDF of x. Okay. That is capital F of x is equal to integral minus infinity to x f of x dx. It is written as minus infinity to 0 f of x dx plus 0 to, you should not wind up with 1, you should wind up only with x. This is what is the difference between finding the probability value and finding the CDF. 0 to x f of x dx. In minus infinity to 0, f of x is 0 plus in 0 to x, that is where x is taking the value from 0 to 1. So, it should be x by 2 dx. This is equal to x square by 4 within the limit 0 to x. So, f of x is equal to, after substituting the limit x square by 4 for 0 less than or equal to x less than 1. We have found out capital, that is CDF of x for one interval, that is 0 to 1. Again, to find out for the second interval, what is your second interval? 1 less than or equal to x less than 2. For 1 less than or equal to x less than or equal to 2, to find CDF. Okay. For this interval 1 less than or equal to x less than 2, we will find out the CDF of x. Again, f of x is equal to minus infinity to x f of x dx. X is taking the value between 1 to 2. Break the interval as minus infinity to 0 f of x dx plus 0 to 1, because f of x is taking only from 1 to 2, up to that you have to keep on integrating. This is what is called cumulative integration, cumulative distribution function we are finding. 1 to, you should not wind up with 2, you should wind up with x, where this x is taking the value from 1 to 2 f of x dx. In this interval it is obviously 0, and in 0 to 1 it is x by 2 dx, in 1 to x it is 1 by 2 dx. What is that equal to? X square by 4 for 0 to 1 plus 1 by 2 for 1 to x. 1 by 4, this value is 1 by 4, and here 1 by 2 into x minus 1. Simplifying 1 by 4 plus 1 by 2 into x minus 1 by 4, you get x by 2 minus 1 by 4. This is your capital F of x for the interval 1 less than or equal to x less than 2. We have found out f of x for the second interval. We have to find out another f of x for the third interval. What is the third interval? For 2 less than or equal to x less than 3, to find CDF of x. So, again using the formula f of x is equal to minus infinity to x f of x dx. How will you break the intervals? Minus infinity to 0 f of x dx plus 0 to 1 f of x dx plus 1 to 2 f of x dx plus 2 to, you should not wind up with 3, it should wind up with 2 to x f of x dx. Okay. Substituting the values of f of x, it is 0, and in 0 to 1 it is x by 2 dx, in 1 to 2 it is 1 by 2 dx, in 2 to x, where x is taking the values from 2 to 3, it is minus x by 2 plus 3 by 2 into of dx. So, how will you get the values? X square by 4 for 0 to 1 plus 1 by 2 into x for 1 to 2, and then minus x square by 4 plus 3x by 2 for the limits 2 to x. This is 1 by 4 plus 1 by 2 this value, then upper limit is minus x square by 4 plus 3x by 2 minus 4 by 4 plus 6 by 2. This is 3 by 4 minus x square by 4 plus 3x by 2 plus 1 minus 3 minus 2, 3 by 4 minus 3 by 4 minus 2 minus 5 by 4. So, your ultimate answer is minus x square by 4 plus 3x by 2 minus 5 by 4. This is your f of x for the interval 2 less than or equal to x less than 3. Now, we have found out f of x for the 3 intervals. One is for 0 to 1, another one for 1 to 2, another one for 2 to 3. Now, we have to write down this f of x in a format. How to write down the f of x in the format? Capital F of x equal to, first start with 0. We have to write f of x in the format as I already told you. Start with 0 and then the first one, what is the first interval? First let me write down the intervals. 0 less than or equal to x less than 1, 1 less than or equal to x less than 2, 2 less than or equal to x less than 3, and this interval is x less than 0, x less than 0, and here it is x greater than or equal to 3. In this it is 1. We have whatever the 3 answers which you have found out for the respective 3 intervals, you have to come and substitute here. For the first interval 0 to 1, it is x square by 4 and write it as x square by 4. What is the second answer? Second answer is x by 2 minus 1 by 4, x by 2 minus 1 by 4. What is the third answer? Minus x square by 4 plus 3x by 2 minus 5 by 4, x square by 4 plus 3x by 2 minus 5 by 4. So, this is your CDF of x for the given PDF which is discontinuous. We have seen this example for a continuous random variable having the PDF which is discontinuous, having the discontinuities at x is equal to 1 and x is equal to 2. The next problem is a random variable x having the CDF. When CDF is given and when you are asked to find out the probability, what to do? When PDF is given, finding the probability, I have defined the relationship between probability and PDF. Now, the relationship between CDF and directly finding the probability. You have to find out the probability only through PDF. So, first what we have to do, using this CDF, you have to find out the PDF. For that, relationship between CDF and PDF should be mentioned, and then you have to find out the probability. First of all, what is the relationship between PDF and CDF is f dash of x is equal to f of x. So, when you want f of x, you should differentiate the CDF. What is your CDF here given? Capital F of x is given as 1 minus 1 plus x into e power minus x. Differentiate it, 1 if you differentiate it is 0, and using UV formula you have to differentiate. Minus of e power minus 1 plus x is kept as it is, e power minus x differentiated is minus 1 plus e power minus x is kept as it is, and differentiating 1 plus x is 1, and ultimately you get minus of minus e power minus x e power minus x plus e power minus x. So, cancelling e power minus x, this is equal to x e power minus x. For the interval, only one interval is given, x greater than or equal to 0. How will you write the PDF? PDF of x is written as f of x is equal to x e power minus x for x greater than or equal to 0 is equal to 0 otherwise. Although it is not mentioned to find out PDF in your question, since you are asked to find out the probability, you have to find out a PDF using CDF, then only you have to find out the probability. So, what is your question? The question is finding the probability that it assumes the value less than 1, that is you are asked to find out P of x less than 1. Again using the relationship between probability and PDF, integral minus infinity to 1 f of x dx, break the interval because f of x is defined only for 0 to infinity. So, 0 to 1 f of x dx, in this it is 0 and 0 to 1 x e power minus x dx. How will you integrate x e power minus x? Using UDV formula, x into e power minus x by minus 1 into e power minus x within the limits x is equal to 0 to x is equal to 1. So, substitute the first limit e power minus 1 by minus 1 minus e power minus 1, substituting the next limit 0 minus e power minus 0. This is minus 2 e power minus 1 plus 1. So, answer is 1 minus 2 by e. So, what is your probability that x value assumes less than 1 is equal to 1 minus 2 by e. In this session, we have seen a continuous random variable having a discontinuous PDF, and you are asked to evaluate the probabilities and the CDF of x, and also when a cumulative distribution function is given, how to find out the probability. When a CDF is given, you can find out the probability only via PDF. So, using CDF find out PDF, after finding PDF find out the probability using the relationship between probability and PDF. This is an example. Thank you.